Hello friends. Today we shall be discussing a very important topic of communication system, that is modulation. This is a general block diagram of a communication system comprising of a source and destination from where the message is being originated to the final destination. Within the source and destination, we can see several blocks of the communication system, and among these blocks, we have a block named transmitter. So transmitter is an umbrella block which contains several sub-blocks which actually process a message signal or a given signal so that that message becomes suitable enough or it becomes compatible for a given channel. One of the important process being done at the transmitter is that of modulation. And today, modulation is the process of varying one or other parameter of carrier signal in accordance with the message signal. So from here we will guess enough that modulation comprises of two signals. One is our message signal, the signal which is intended to be sent from the source to the destination, and another signal known as the carrier signal. Okay, and the name carrier suggests that it carries the information from one point to another. Okay, so modulation comprises of two important signals: the desired signal, also known as modulating signal, or baseband signal, or information signal. Another important signal is the carrier signal, and this signal is a high frequency signal. So what happens in modulation, that one or another other parameter of the carrier is varied in accordance with the modulating signal. Okay, and this modulating signal is also known as baseband signal. Why the name baseband? Base means low, because this signal comprises of relatively lower frequency components, whereas the modulated signal, the signal which has been generated using these two signals, the carrier and the message signal, is known as the passband signal. Okay, also known as modulated signal. So modulation, the very general term of modulation, means change. Okay, so here the desired message is changing the characteristic of another signal known as a carrier signal, and these changes are nothing but the reflection of the information. Okay, the information is reflected in the changes done upon the carrier. Okay. So depending the carrier to be continuous wave or in the pulse wave, there are certain characteristics, namely the amplitude or frequency or phase in case of continuous wave signal, whereas amplitude, width or position in case of pulse wave signal. Okay, so in modulation what happens, at any time any one parameter is being changed in accordance with the message signal, whereas the other parameters, other characteristics should be kept constant. Okay, so this was about the change. Another feature of modulation is that of frequency translation. Okay, because as we said that the message signal is having base frequencies or low frequencies. Okay, suppose the frequency of the message signal is FM, so this is of a lower value. Why am I saying lower, or a relative term I'm using? Because I'm comparing it with a higher valued frequencies, which is that of the carrier signal. Okay, suppose the carrier frequency is represented as FC, so this FC should be very, very high in comparison with the fundamental frequency of the message signal. Now, what is fundamental frequency? Because usually the message signal is not comprising of a single tone or a single frequency. It is a bunch of several frequencies. Suppose my speech, what I am saying, if my speech is being analyzed on a spectrum analyzer, or if the frequency components are being looked at, it will be containing a range of frequencies. So the highest frequency component present in a given message would be known as a fundamental frequency, and usually the message signals comprise of a range of frequencies. Okay, and the highest frequency component will be known as FM, or the fundamental frequency. So the carrier frequency that we are selecting should be much higher than this frequency. Hence, the frequency translation takes place in case of modulation.